15 ways in which we've deployed Orthanc so far. 50 was more to get an overview of the film that we had recently. So I'll start by explaining what the Orthanc project is. I'll then explain those 15 use cases, and I'll, in the third part, explain how we declined this open source model. How we actually worked out an open source model. So let me start with what Orthanc all started with. It started with the concept of 33 million medical images being taken every year in Belgium, and 20 million of those still being burned into CDs, which is a huge waste of money. It's not ecological. Also, 40% of images appear to be done for no reason, just because we don't have access to the image. So that's waste, and it's basically due to two issues: interoperability. We've discussed it very largely in the last two talks, and even before. And also standards. We just had a very nice discussion about it. So, what issues does that cause? Well, first of all, we can't. It's difficult to transfer images within departments of a hospital. It's difficult to transfer images among hospitals, even worse. Hospital-to-patient communication is getting better, but it's still troublesome. And where the shit really hits the fan is among physicians. There, it's a big issue. So the solutions that are currently in place are threefold: either we burn CDs, or we make VPN tunnels that are very difficult to maintain, or there's custom proprietary code, which is built by dinosaurs, basically. The big 4 or 5 people that are there in the place and that are trying to lock down the field and try to lock down the market to just make sure that they can make enough money. It's a bit of a pity, while actually the water that is running here is accessible to anyone, and anyone should be able to access the water. And that's how Orthanc came to live. It was actually built for the internal needs of the University Hospital of Vienna. They had issues sending the medical imagery that was shot, in the medical center, in the radiology center, and that had to go to the radiotherapy center. Sebastian was hired to develop this bridge 5 years ago, and then he basically started creating the software that slowly came to become an actual PACS, and even more, it's more of a toolkit PACS, and it's very hybrid. Sebastian won the award for Advanced and Free and Open Source Software, and it was granted by the Free Software Foundation at MIT, and thanks to that we created a spin-off. So how does Orthanc compare to the traditional players in the field? Well, basically, we're open source, of course. We make sure that the DICOM standard is always respected. We have a REST API on everything that is available in Orthanc, so the full data model is RESTful. We're multi-platform, so we can deploy on Mac, PC, or Linux, and it's web first. So we can collect images, store images, and do workflows, view images, just like any regular text would be able to do that. We're better basically in sharing images and integrating with other systems in the hospital. So bottom line, we enable innovation where others try to lock down innovation so that they can stay ahead of the competition. A small pictogram to explain what Orthanc is all about. It's very difficult to explain. So it's a PACS, but it's also a banking toolkit, and very importantly, we were very web-oriented, so that everything can be accessed via the web, and we don't need any other protocol. Why people love Orthanc? Basically because it's open source, and the community is there to guarantee the quality of the code. It's interoperable, it's vendor neutral, and it supports the DICOM standard, so it's less issues basically. It's standalone, so you've actually got everything in one. If you deploy deploy an Orthanc instance, you can start drag and dropping images right into it, and then it's actually storing it. It's got a DB built right in it, and it's very light to install. It's cross-platform, as I already said, and it's extensible. So you can deploy a very simple version, so it's very lean. And then from there on, you can start adding plugins. You can do scripts to automate stuff. And yeah, as I already told, there's a RESTful API. It's industrial grade and it's free. I think that's one of the major reasons why they love it. Some figures, so it's a one core application with 5 plugins. So the core is what does the storing and stuff, and then there are 5 plugins. So the web viewer, which enables viewing of images. There is a PostgreSQL plugin, a DICOM web Annotate plugin, which all amount to about 150,000 lines of code, thanks to Sebastian and the community, of course. And the application has been downloaded 50,000 times so far. At least that's the figure that we know of. That's a packaged version that has been downloaded 50,000 times. We don't know how many people have downloaded the non-packaged version. A quick demo. This is what Orthanc looks like. It has an Explorer built right in. I hope the network is going to support this. So this is browsing study into the different series, the different instances. I can open the series and then hopefully browse within that. Start browsing. That's a basic viewer. It's only 2D. Nothing really complicated, but it already covers like a big percentage of the needs. Let's go back to presentation. And give you a showcase of the 15 ways Orthanc has been implemented already so far. So this is the most basic version. A small clinic wants to integrate images from different modalities, wants to store that on a central text so that different doctors and clinicians can interact with those images. Very basic. The second implementation is actually the one that Sebastian got to start working on, because they had to get the images from the PACS to the radiotherapy center. Had to integrate images from other hospitals, other sources. So he started working on CD ingestion and enabling sending images from that Orthanc instance into the PACS and then getting it back out of the PACS so it could all be sent to the radiotherapy center. Another implementation that is taking place is one in the south of France. The PACA region has 60 hospitals that have integrated their emergency rooms with Orthanc. So each hospital has an Orthanc on their PACS system, so that a central radiologist can have a look at those images, so they can actually economize, save a lot of money in not having to have an emergency radiologist in each hospital. So it's, they saved a lot of money thanks to that. Another instance is a vendor that has used Orthanc to enable multidisciplinary, I don't know how to say that in English, but multidisciplinary. The tumor board, exactly. So basically, different Orthanc instances are being organized so that they send a specific set of images to one centralized Orthanc instance, and then the tumor board can have a look at those images, and they don't need to drive around or to meet physically. And third-party application that uses Orthanc as a library. So basically, Orthanc, as it's lightweight, it can be installed on the cloud. And there's an application running on one hand side and Orthanc running right next to it, actually in the back end. And they can just go and grab images from Orthanc and display them in their app so that they can use it. In this case, it's for a medical case application where specialists have to intervene in order to to do expertise research and define whether what was the cause of an accident or something like that. This is an application where different hospitals have been interacting. So basically, Hospital A sends an image to Hospital B. There's a reconciliation tool, and then this stores data into the EHR and into the PACS. So this reconciliation is automated, but in case of exception, there's an interface that the user can use, and it's all custom built. It's also being used for multi-centric clinical trials. Basically, what used to be happening before is that imaging sites had to take images of patients, then burn them onto these CDs, but before doing that they had to anonymize it, and then send it to a CRO, who then in turn had to send it physically to a teleradiologist first for quality purposes to check whether the quality of the image is sufficient in order to be used in a clinical trial. And then at the end of the clinical trial they had to do the full analysis to check whether the efficiency of the drug is there. And what we do with Orthanc is we connect different PACSes with one central Orthanc instance in the cloud, and the different users can actually interact with different access rights to those images in the cloud, and so we don't need to have any physical CDs being burned, so we're saving a lot of time. And also, we don't need to do any calls anymore. Everything is in one app and it's all centralized, and everyone actually wins with this. Research centers have been asking us to set up Orthanc instances in the cloud so that they can ask their the hospitals that are working with them to centralize the images on one central Orthanc instance, and then they can run their post-processing algorithms and do tests on them so that it works smoother. A very basic implementation of Orthanc is basically ingesting CDs. So you can use Orthanc by having it installed on your computer, and then as soon as you enter a CD in your computer, well, very few computers still have CDs, but basically, as we still use CDs, it's used for that. So it ingests the CD and sends it to the PACS. The other way around, we've recently been asked to make a program that can be burned onto a CD with a medical image on it. So basically, we made a CD burner. We did the process the other way around. It's still there. Some people are still asking for that, so we can do that as well. And there's a viewer that is the viewer that I showed you that is installed on the CD. Then and you just enter the CD in your PC, and then it fires off the study. This is a case that we're presenting tonight for the hackathon. There are a lot of echographs that are basically Robinsons in the hospital industry. They're like cut off the rest of the world, and they're not connected to the PACS because it has not been foreseen. So what we're offering as a solution is you connect, well, we install Orthanc on a Raspberry Pi, which is a very small device. We connect a USB key to that Orthanc instance. This is then connected to the hospital intranet, and it enables the user to say, well, this image is for that patient, and then it will store the study onto the PACS and update the EHR and informing the HR or the fact that this study was uploaded. This is just to show you how broad the scope is that Orthanc can handle. We can store anything that is DICOMized. So as Sebastian demonstrated earlier, we also do, on top of the traditional radiology, we do everything that is ANAPAT, but also you can DICOMize any JPEG or MP4, as was demonstrated, and also DICOM DE, which is a standard that is being developed for industrial use. So it's X-ray for industrial use. Non-destructive testing, exactly. And then lastly, LIFE is the application that we're developing, the spin-off is developing. So it's a software as a service that basically uses the entire strength of Orthanc. It's a packaged version of Orthanc that has an interface to it. And what it does is you can install it on any PC, on any Mac, and then you can connect it to a PACS, you can connect it to any modality, and then you can get those images coming onto your Orthanc instance, which is called LIFE. And you can then start sharing it. You can share it internally with, within the network, but also you can store it on, synchronize it with the cloud, so that you can collaborate on it with other people. And then once it's in the cloud, you can also run it across different post-processing algorithms that we're, of partners that we'll be working with. I wanted to do a quick demo of that as well. So this is our interface. We have a first preview, which is basically the basic viewer that I showed you earlier. And we've got an advanced viewer that enables you to do annotations and so on. Every time you make an annotation, you have like a hotspot here, and then you can start creating your report by just dragging and dropping these hotspots into your reports. You can also add notes. And then you can start sharing this this study. So you can password protect it, of course. You can anonymize the study. There will be different anonymization profiles that you can set yourself. You can require identification, and this will actually post it onto a personalized publication portal. Then we're working on a capability to share the screens, which will basically enable telecollaboration. You'll be sharing a link, and those people that will be clicking on that link will have the same screen as you. They'll have their own cursor, and there will be a teleconference running in the back as soon as they've clicked on the link. Let me maybe quickly go back to the app so that I can show you the facts. So you can do a query retrieve here, and then when you double click this image, it will land in your inbox. You can connect different modalities that will actually be spitting DICOM files into LIFE. You can then organize the data into different folders. And one of the nicest things I think about LIFE is that you can collaborate with different organizations. So you've got your own organization, but you can be working for different hospitals. And within each hospital, you're granted access to a specific folder. So in this case, this guy is working for 3 different hospitals, and he has his specific access rights in each hospital. So that was for LIFE. About open source model. So Orthanc, as I think you may know by now, is really like an engine. And Sebastian showed you a Swiss knife. Maybe that's a better analogy even. And actually, Optimus, which is a spin-off, comes in as a mechanic who's engineering things. We're asking hospitals what they actually want, and then we can make it for them. Anything they ask, we'll try and make it for them. And most of all, we're trying to automate things. We try to help hospitals to make things become more natural and to correspond to the flow that they actually want. And then a last slide about the open source model. So Orthanc is fully free and open source. They, as I told you, there's one core application with 5 plugins. Osimis also does free and open source software. The viewer that we showed, that I showed you in Livey is actually open source. The only thing is, if you want to be using the open source viewer in a certified way, then you have to pay like a partnership fee. So you become a partner of Osimis, and then you can start using it commercially. We can also do, of course, Osimis can also do on-demand deliveries of specific custom code. And then there's the SaaS model, which in some ways is not compatible with open source. It is, we use open source tools. Anyone able to code would be able to recode what we did. But we can't call it really open source. And it definitely is a commercial way of distributing Orthanc. And in everything we do, we'll make it RESTful. We'll always conform to the DICOM standards. It will always be multi-platform and busway. That's it. Thank you for your attention. Any questions?
So when you develop with annotation and the reports, you are creating a presentation states and local size, and you are creating something which is specific.
I think we've analyzed different options for that. For the moment, we're doing that as it's mainly prototyping that we're doing. It's we analyzed 3 options for that: either storing it into the DICOM file in one of the tags, or storing it into the application that's running next to it. Or the third option was to do it in a Firebase, but that is like quick and dirty, so that will never be a viable option.
You may know that it's perfectly documented in DICOM by creating a presentation.
Absolutely. Yeah, yeah. And which is what we're eventually going to do, of course. Yeah.
Business.
Sure.
It seems like a really great but quite innovative thing to use. How difficult was it to integrate it into the practice of practitioners that need to use it? You have to do a lot of education to actually show them that they might use a little bit of time learning how to use it, but then eventually they have amazing advantages for their practice.
Mm-hmm. Life is currently just a prototype. It's you can use it. We'll try and work with it on the internet, but it's not interactive yet. There's no database that will be storing files that you're dragging and dropping in there. We'll be going live in May, and so we'll be working with beta testers for the moment. And only then I'll be able to answer your questions. For the moment, the feedback we've got so far is very positive. The learning curve seems like to be almost inexistent, and people that have the issue of using DICOM and CDs, well, they prefer learning using this curve than rather than having to figure out how to use a CD and things like that. So
Eventually you want to sell it directly to physicians or by hospital?
I think mostly practitioners will be using it in the first time. Hospital use of Livey will have to adapt Livey to their specific needs. It will evolve. We're really hoping to be lean, start with those that have the biggest problems. Well, hospitals have the problem very, very much, but they're not necessarily inclined to change. So.
Okay, thank you.
I had a question about, I saw a lot of Orthanc presented in the cloud.
Yes.
I think this is not in France.
It is in France, actually, but when we say cloud, that can be a private cloud. That can be just a server somewhere in a cluster of hospitals, which is managed by the same group of hospitals. So whether they'll be storing it on their server in one one hospital or on a centralized server is the same thing. But I know it's an issue in France, and we're still trying to figure out how we can solve that.
Like S4.
Yeah, we're actually thinking of becoming ISO 27001 certified, so we're actually granted the right to store medical data.
Okay, thank you.